Guys, why is there talking?
Funny.
Real quick, on that last quiz, the one, the inverse quiz.
Oh.
6 people got it correct out of 60. 5 were in this room. So, can we get a little give it up for Nathaniel, Marco, Amina, Letke, and Chris? Everyone else has these up. I'm not going to score these, but I want you guys to look over these again. We had some of these up already. We had these up already. What I'm going to do, if you got it, you can use this as you can make it up for a 4. Does that make sense? So hold on to it. Does that make sense, you guys? So if you get like a 2 or a 3 one time, and you can kind of change it in. What is that number on the bottom of the sheet? If you got d dx, f inverse of 1, what is that 1 in terms of the original function that you have? It's the y value. So how do you solve for the x value on the original function?
Plug in the y and
Yeah, I mean you could do that. You can. Probably the easiest way is to graph it. You know what I'm saying? Like in the calculator, find the intersection point. Find the x value when the original function equals y. Does that make sense? Or all of the cases, if you notice, it's all x equals 0. Do you guys notice it? Take a look at the equation. If x was 0, wouldn't that be the y value in yours? So knowing that, how do you answer this question, or whatever, this number was different and the equations were different, but all the x values were 0. So how do you do it? Talk about it in your proofs.
Hello?
Can you guys get it now?
No.
Does it make sense? It's a trick. You know what I'm saying? It's a trick. Yes? Does that make sense? So yeah,
Hey.
You got it right.
Which one? What equation? Let's see what equation. No. Which one did you get?
So this is what we're training for. You know what I'm saying? You know. You did it. Okay, I'll go over them one more time. If I can find them. Oh, give me some. Here it is. 1969, right?
Yeah.
All right. What's the first problem number? What does it say?
1.
No, the number. It says like 1969-1. 1 is B.
Hey, I got it right.
What's the next one?
5.
5 is E.
Whoa.
Next one?
6.
6 is B. 18 is E. 20 is A. 22 is E. 24 is C.
What?
39 is D.
1973.
1973, 3 is B.
How do you do this?
We'll talk about it. That's what we're doing right now. That's what's after this. What's the next one?
4. Next.
4 is A. 6 is D. 8 is B. 9 is A. Next one, any more? Alright, so check through what you got. Check through these problems, you guys. Help each other out. Check through the multiple choice. What did you miss? Was it something small? Was it a little trickaroo? We can go through a couple together.
Wait, 1973, number 8.
As expected. Nothing amazing other than wonderful Jones students.
Oh, you don't like the WLS?
Alright, does anyone have any questions on these? 41? Hey guys, while you're working, I'm going to put up 41 on the board, kind of like how I would do it, I guess. I'm sorry, yes. Over here if you want to check it out. Now, the one thing about problem 41 is the origin, it says, you know, at the origin. Well, the origin is not part of the e to the x function. It's not the point, which is kind of hard. So it's like, what do you do then? You got this graph. Here's e to the x. It wants the tangent line to this graph that also goes through the origin. Well, I don't know, maybe something like this. But I don't know what that point is, you know what I'm saying? So, the only thing I know is that this tangent line goes through the origin. It goes through this point. And then it goes through some point like, you know, x comma e to the x, or however you want to look at that point. You know what I'm saying? The x and the y value at that point. You know what I'm saying? Which if you want to call it a and e to the a or something. This is the only thing I know about this blue line. It goes through this point, and then at some x value, its y value is e to that x value. So going old school, the slope of this line would be y2 minus y1 over x2 minus x1. E to the x minus 0 over x minus 0 would be the slope, yes, of that line. I also know the slope of this line at this point by using what method? Take the derivative. So if I take the derivative at this point x for e to the x, what do I get? What's the derivative of e to the x? So the one thing I know is that two different ways to represent the slope of that tangent line, so those slopes have to be the same. So the problem is, so I'm still stuck with this, e to the x equals e to the x over x. And then, I don't know, you can try to figure out like what point would make that true. Does anyone have any ideas, like what x value will make that true? 1 will do it. Does that make sense? If x is 1, then this is and then it's e to the 1 equals e to the 1. But if it's anything else, if it's 2 or what, it's not going to work. Does that make sense? So you kind of have to look at it and say, oh, okay, I guess it's 1. So the point on the graph, this point is the point 1 comma e to the 1, or just e. Okay, that's the point on the graph. And then what's the slope of this graph at this point? At 1 comma e on the e to the x function, what's the slope? E. You put in the x value in to the derivative, and you get e. So with your point and slope, you can plug it into point slope. So kind of a trick, but just what's interesting about this is just the idea. If you don't have the point on the graph and you have another point, what you can do is just kind of say x, y. You can do the slope of the tangent line old school and set it equal to new school and see if that'll help get something out of it. Does that make sense? Because you don't have anything else. All right, let's check through those AP problems from 69 and 73. Talk about them, let me know if you have any questions.